It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 298. Suppose the function f is twice differentiable, and the table above gives the selected values of f, f prime, and f double prime. Which of the following statement is true? Okay, we have 3 statements to think about. First one says f is decreasing in this interval, concave up in this interval, and a point of inflection at x equals 3. Here, is f decreasing in this interval from 3 to 5? Well, if f is increasing, then f prime must be negative in this interval, right? In the interval from 3 to 5. So let's look at this value right here. If we look at these 2 values, when x is 3, f prime is negative. And when x is 5, f prime is negative 2. Both are negative, right? But we don't know what happens between these 2 values. Let's say we could have at x equals 3.5, we could have a positive y prime. Let's say y prime is 2 or whatever, right? At 4.2, we could have a positive y prime, f prime, right? Let's say 3 here, right? So we're not sure. We can say that in this interval, f prime is always negative, right? So this statement is not true, not always true. Okay, does that make sense? Okay, second part, f is concave up in this interval right here. Okay, this one too, from 2 to 3, when x is 2, f double prime is positive. When x is 3, 0, right? But between 2 and 3, we don't know what the values of f prime are, right? Let's say when x is 2.5, we could have negative f double prime, let's say negative 1, right? Then f double prime is not concave up at this point, right? So we don't know what values we have between 2 and 3. So we cannot conclude that f is always concave up in this interval. Does it make sense? So this one is not true. Okay? Okay, third part. F has a point of inflection at x equals 3. When x is equal to 3, f double prime is equal to 0. We have a point of inflection whenever f double prime changes its sign from positive to negative or negative to positive, right? It looks like it changes from positive to negative, but we don't know what... here, let me draw the line. I'll show you. When x is 2, f double prime is positive. Let's say positive 3 here. When x is 3, let's say here's a 3, here is a 4, it is a 0 here, and when x is 4, it's a negative 2 here. Okay, but we don't know between 2 and 3, and 3 and 4, right? We could have this type of graph, f double prime, like this, right? Then at this point right here, f double prime is negative here, right? And negative here, right? Then this is not going to be point of inflection. Do you guys see what I'm trying to say? So we don't know what happens between these 2 values and these 2 values, right? Before 3, it's not always equal to positive. After 3, it's not always equal to negative. Do you guys see that? So we cannot conclude that this is a point of inflection. Okay? So this is not also true. So the answer for question 298 must be A. Okay?